Welcome to The Explainer. Okay, we have all been there, right? You ask your AI coding assistant for help, and 1 minute it's a total genius, and the next, it's like it has no idea what you're talking about. So, how do you get a handle on that inconsistency? Well, today we're going to break down the mental model that you need to transform your AI from a frustrating roll of the dice into a truly reliable team. It is a feeling every single developer knows. 1 minute, your AI is spitting out perfect, beautiful code. The next, it's just complete gibberish. So what is going on here? Turns out the inconsistency isn't really a flaw in the AI itself, but a flaw in how we're thinking about it. So let's start by busting the biggest myth of them all. You see, if you want to get consistent results, you have to completely shatter the main assumption we all make about these large language models. We tend to treat them like they're compilers, but here's the thing, they are not executing a single line of your code. And what's really going on is way more interesting. So here's the myth. We act like the AI is a runtime environment, that it can execute our code, understand it, check the types, but that's not what's happening. The reality is that an AI is a language processor. It's not running anything. Instead, it's just recognizing patterns in the text. It's matching the shape of your code to the billions of examples it's been trained on. To an LLM, your code isn't logic. It's just another dialect of human language. And once you get that, all the weird behavior suddenly makes perfect sense. The AI writes beautiful, clean code that's totally impossible because, well, it looks right. It just hallucinates APIs that seem plausible because they fit a pattern it's seen before. It has no real understanding of your project. It's literally just finishing a sentence. So, okay, if it's not executing code or thinking like a compiler, how in the world does it know what to do at all? How does it turn your prompt into something that's actually useful? Well, it acts like a detective, and you're the one leaving all the clues. It looks at everything, your variable names, your function names, your file structure, your comments, even your coding conventions. It's piecing together your intent from these little linguistic breadcrumbs you leave behind, not by actually running the code. And this is just a perfect, simple example of what I mean. A function named h of h gives the AI zero clues about what it's supposed to do, but a function named handle user, that gives the AI a powerful anchor to grab onto. So all of a sudden, clear naming isn't just a nice to have for your human teammates, it's a direct instruction for your AI. This brings us to the next critical piece of the puzzle, documentation. But hold on, before you start thinking you need to write a novel for every single file, the key is not to document everything. It's about being really, really strategic. So does making your project AI-friendly mean you now have to document every single line of code? Is that the big secret? No, absolutely not. That would be a complete waste of your time. The key isn't exhaustive documentation. It's high-leverage documentation. A few well-placed, strategic comments will give you an exponential return when it comes to guiding your AI. And for the biggest possible impact, you really want to focus on these 4 areas. First, document the boundaries, what a module does, and just as important, what it doesn't do. Second, explain the intent, the why behind the code. Third, establish a clear vocabulary for your concepts. And finally, document your high-level architecture. These 4 things give the AI the context it's desperate for. Just look at the power in that second sentence. Simply stating does not execute the tool draws an absolutely critical line in the sand for the AI. That one little comment prevents a whole category of potential errors just by clarifying the function's limits. This is what high-leverage documentation looks like. Now, as powerful as strategic comments are, there's actually another technique that gives an AI even more clarity. In fact, for a lot of us, this is probably the single biggest aha moment when you're learning how to really work with these tools. So what is it? What's the single most powerful signal you can send to an AI to help it understand the entire map of your project? What's even better than a perfectly placed comment? The answer might surprise you. It's your project's file and folder structure. A clean, logical, and predictable structure is the ultimate guide for an AI. It's like you're handing it a perfectly organized blueprint of your entire application. I mean, just look at this structure. Without reading a single line of actual code, the AI can already guess a huge amount about what's going on. It sees a folder for an interpreter, one for tools, and another for schema. It immediately understands the separation of concerns. The file names themselves describe their purpose. That is an incredibly powerful signal. And the reason this works so well is that it leans directly into the one thing that AIs are amazing at, pattern recognition. You know, all those principles we already know are good practice, single responsibility, small files, clear naming, they create these strong, predictable patterns, and the AI can latch onto those patterns to understand the context across your entire code base. So, with all that in mind, let's finally throw out that old, flawed magic compiler idea and replace it with a new mental model, one that's going to fundamentally change how you interact with your AI assistant from now on. Here it is. From now on, think of your AI as a very, very fast junior engineer. This engineer has a perfect photographic memory of every single code pattern it has ever seen. But, and this is the most important part, it has absolutely zero ability to read your mind or guess your intent. If you don't write it down, it simply does not know. This table breaks it down perfectly. It translates your project into a language that this new junior engineer can actually understand. Your code, that defines the behavior. Your docs, that's the intent. Your clear names, those are the anchors it holds onto. And crucially, your project structure, that's its memory map, showing it how all the pieces connect. And this quote just sums it all up perfectly. LLMs reason in language patterns. And that's exactly why communicating clearly with your new junior engineer through names, structure, and intent matters so much more than the nitty-gritty implementation details. You're not just feeding instructions to a machine anymore, you're communicating with a teammate. And that leaves us with a final, very practical question. Looking at your own projects through this brand new lens, what's the very first change you're going to make to help out your new, very fast junior engineer?
He had